Hi, I'm Nick Spano. I taught geometry for almost 40 years, and I have an invention for finding the center of a circle in the fewest arcs or lines ever done in history. Euclid, whom I respect very much and who was the father of geometry, did not find the center in less. I also found the diameter in fewer than anybody in history. We are using Euclidean tools, and the Euclidean tools are a compass and an unmarked straight edge that you can't use as a ruler for measuring things. So let's zoom in here and I will show you. The first method uses 8 lines or arcs. And it starts by drawing a chord, which is a segment with endpoints on the circle. And I'll just put them in here to show you. So that's 1. And then we know from our geometry constructions that if you open up your compass to intuitively more than half, which you're allowed to do, and you draw an arc, and then without changing the compass setting, draw another arc, you now have 3 arcs or segments. Then connecting, and we can call a segment a line, it doesn't matter, because right here we're going to connect these 2 points, and we will have, this is for instance more like a line, and we would put arrows on it, but it doesn't matter. This is actually a diameter from my 2 fingers because it goes through the center and it is a straight segment. It's the longest chord of the circle. Now in 4, we had 1 in any order, 2 and 3, and 4. So this is what we have so far. If you duplicate this and start with another chord somewhere on the circle, and that would be 5, and then let's do the same thing, and you can change the compass setting now if you'd like. You just have to have it more than halfway. So let's go like this, and again we draw the arc. That's 6 and 7, and it makes what we call, or what looks like, a football shape. So that was 5 and 6, and let's see, 5 and 6 and 7, and now when we connect the 2 points of the football shape, we end up with the center of the circle, and that was done in 8 steps. So that is how some people do it. The second method is done with 7 steps, and I will show you how that is done. Okay, so the very first way we did it, and I can put my points anywhere. This is the first. Again, this is a chord. And then that was 1. This will be 2. And again, we wanted to open it up to more than half. So this is 2, and this is 3. And this is 4. Again, we have a diameter in 4, the exact same way as before. And the diameter would be from here to here. So again, I will show you 1 in any order with the arcs 2 and 3, and the diameter is 4. Now, somebody used this method. Once we get this, then they bisected this. Okay, they bisected the diameter. So let me turn it this way so you can see it a little better. And when you bisect the diameter, we'll show you what we do here. Okay, this is going to be the perpendicular bisector of the diameter. 1 more, that would be 5, and 6. Again, the football shape. So these are 6 and 7. I'm sorry, 5 and 6. And then we connect these 2 points again of the football shape, which again makes a diameter on the circle. It's the longest chord. These 2 diameters have to intersect at the center, and this was done using 7 lines or arcs. So we beat the first method by 1. Let me show you the comparison. The second part of the construction was done more efficiently. Now, both of those used the same first 4 steps, and that's how many it took for them to find the diameter of the circle in 4 steps, and 8 or 7 to find the center. Now, the next part that I'm going to do is I'm going to show you the method I have. Mine's an imaginary chord, an imaginary segment, and it's a chord of the circle. So let me show you what I'm going to do, and I'm going to just move them over this time so you can see it really doesn't matter where you put them. See, now if I connect it to be a chord, all I have is the endpoints of that chord, so I don't have to count that. Again, I open up my compass to more than half. That's an intuitive measure that's allowed, an intuitive quantity, I should say, that's allowed under the rigid rules of Euclidean instructions. Now, watch what I have here. There's only 2. Football shape, connect the endpoints of that football shape, and where it intersects is a diameter in 3. Now the interesting part of this, we could do it again and get down to 6. But how about this now? If we say, well, we've already used one of these or both of these arcs, so look, I'm just going to come right here now. And without changing my compass on any of those 3 arcs, I'm going to do this again, make another football. And even though it's close, you know, it doesn't have to be to the other point. Here's my football. So I went 1, 2, diameter in 3, and then from here I have 4 and 5. 4, I'm sorry. And then 5 would be this one here. And we again use the 2 points of the football shape. And that's another diameter. And the 2 diameters in only 5 will cross at the center. So that is also 3 for the diameter, 5 for the center, are both records. Now,